Okay. 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 Hey guys, Namaskaram. Welcome to the CET Techloop event on behalf of IEEE VIT in association with IEEE CET, where we are providing you an intro to five mainstream domains during these 5 days. My name is Jasim and I am pursuing BTech in VIT Vellore. So today we are at the second day of Techloop CET and I'm taking the session of Android app development session for you guys. So let's start the session, shall we? Okay, okay, fine. So I would like to know, yeah, hi guys, how are you doing? Um, so I would like to ask you guys, how many Android users are in the group? Okay, no response. Okay, yeah. Okay. So there's no one here who haven't heard about Android, right? So can anyone here tell me what comes to your mind when you hear about Android? Yep, it's definitely Android. Okay, yeah. So we'll be defining Android right now. Android is a basic operating system by Google, which is based on a Linux kernel. It is used by most of the people worldwide as products as smartphones, TV, hell, even in Watch 2. They are in Watch 2. Um, Hundreds of millions of mobile devices are powered by Android in more than 190 countries of the world. So here's another question for you all. Who what do you think when do you think Android was formed and founded, and was it actually Google actually itself? Can you just guess it and say comment in the chat section? Okay, the we are not in anything. So yeah, so I will describe that. So Android actually began in 2003 as a project of the American technology company Android Inc. to develop an operating system actually for digital cameras. So in but and actually 2004 the Android company called Android decided to make it for smartphones. And finally was it was bought by our famous company called Google on 2005, and Google launched the first version of the Android platform in 2007. So the next one might be a bit of a twist to it. So actually Google bought the Android, but actually it's still run by another faction of society. So Android, after it became famous from all over the world in 2007, has not been fully in the hands of Google at all. Whereas there was an alliance formed of 84 technological and mobile companies called Open Handset Alliance, in short form of OHA, whose goal is to provide open standards for mobile devices, promote innovations in mobile phones, and provide a better experience for consumers at a lower price. And of course, Google sponsored this alliance. So the next thing we can know about is that Android was a bit more innovative with the names of desserts. And the reason for this, and I quote this, was by Android. Since the devices make our life so sweet, each Android version is named after a dessert. So sweet, right? So we can also remember that even it became a national controversy in India about Android to name a version of Android as one of Kerala's desserts. So, does any one of you know what dessert what that was and which name it turned out to be actually? Um, okay, so actually that was Android for Android N, and the dessert's name was Neyyapam. Okay, so and it actually turned out to be nougat, but that's not the thing here. So yeah, many controversy was going on over that, and yeah, we know. So On to the next slide, and there are see on to the next slide we can see there are various versions there list from alpha, beta to all the desserts called cupcake and to pie, and then they shifted back to giving out numbers like 10, 11, and now it's the version 12 is in the beta version. So just look through them and see if you can remember each of the desserts name. And also in the right side we have given a I have given a beautiful collage of what means to be a game, which instilled in Android, and see if you can see that. Okay, so let's move on to next. So that's been amazing, right? But there might be still a question hiding in our thoughts. Why Android? Is it actually essential for us to invest our time in studying Android development? So let me tell you some real facts about Android. Around 2.5 billion people use Android every day. So that means Android lets us reach 88% of worldwide population at the moment. And that also means it conquered 75% of the global market share by the end of the 2020. And this trend is going bigger day by day. And today, with more than 400 unique companies bulk producing 4,000 plus varieties of devices, there's an Android device available to anyone. So let's talk statistics now. So till now, around 2.8 billion apps have been published on Android, and the Android itself made a revenue up to 40.3 billion in 2020, and from that, Google Play Store alone made a revenue of 38.3 billion. Wow, a real factor, right? So we could see how billion-dollar companies like Amazon, Uber, Facebook all make the billion revenues just from these apps, and it's amazing to see how much dependent they are on these applications of Android. And these apps we can just get on a click from our smartphone. Well, we know you know how we say it. This is business. So yeah, nice. So what do we need? What do I need? So you're ready to make some app, right? Till now, what we saw, what is Android? So let's see what all are the tools required to make the Android app. What we need is an IDE called Android Studio, which is the official integrated development environment for Google's Android operating system, built on JetBrains IntelliJ IDEA software and designed specifically for Android development. And of course, we need an Android emulator or a phone connected to the machine you're working on to debug or view the content we are making the app. So about Android Studio. Android Studio generally takes up a lot of resources of our machine, and this can be quite the experience you can get from it. Okay, I think you got. Then for so now we have the required tools, but we still need a coding environment consisting of the necessary coding languages required to make an app. So let's get on to it here with our tech stack for Android development. These are the required go-to languages for the native development of Android platform. Here they are Java and Kotlin. First, we can take about Java and Kotlin, which are the brain of the Android app, where it controls everything in the background. Java was the mainstream coding used for Android development in the early days using Eclipse. But then Kotlin was released officially by Google in 2017, and it had a big revolutionary change for Java users to migrate to Kotlin users, and it is now mainly used for because of functionality and many things. So either Java or Kotlin is needed to make an Android app possible. We can continue on this topic later. So next thing is, and the third image you see here is an XML, which is the face of an Android app, which is basically the front end where we place and set up the UI of the app, including the color themes, layout, etc. So what XML is an extensible markup language and it is a markup language that defines a set of rules for encoding documents in a format that are both readable by human and machine itself. Okay, so does anyone know the fourth pick given here means? Oops. Okay, so well, its full form is object-oriented programming, and there is no S, of course. It's just OOPS has been everyone. Everything in Android is done. So, what is OOPS? Let's see that slide there. So, yeah. So, yeah, object-oriented by Abhijit Narayan. So, everything in Android is done on basis of objects and classes, and OOPS is a concept that stands for it. OOPS is actually one of the main foundations of Android development, which is essential, and it helps us in many ways to integrate an Android app with its modularity, flexibility, reusability, and effectiveness. Okay, Savi also said the correct answer there. Then it is also a concept of modern programming languages that allows programmers to organize entities and objects. Four key concepts of OOPS, which are generally known to everyone who studied, then that are abstraction, encapsulation, inheritance, and polymorphism. So, yep, and that's about OOPS. So let's go to the next slide, which is, so this is a topic I skipped earlier to make an explanation separately. This is one of the topics that is the civil war on social handles and tech forums of many developers worldwide on which language to actually choose, Java or Kotlin. Java, as you guys already know, is one of the major programming languages we have heard, and some of us might have used it or studied it once till now. Java can still be used in Android Studio, but Kotlin have the advantages over here, guys. And Java to be used more than Java these days. So let's look into Kotlin actually. Kotlin is a general purpose programming language that is good for Java Virtual Machine, which is also called as JVM. And JetBrains is the developer of Kotlin. And it was released, as I said earlier, on 2017, and it has a capability to be used almost everywhere where Java is used. Kotlin has been officially supported by Google for Android development, and it releases libraries based on it. And next, we can look at some of the Kotlin features that eliminates Java, that does not eliminate, that overcomes Java when we use it. And yep, so first, Kotlin eliminates the issue of null reference, that is also known as a $1,000,000 mistake, which in Java throws the null pointer exception during execution. And this can lead to application failure or system crash when we use Java, but in Kotlin, that's not necessary, and it will be fine after that. And secondly, it eliminates a huge amount of time and code to be written for the same task to be done on Java. So let's look at here, because like Java requires a lot more coding than Kotlin, but it has the same functionality as it is, and more. We have more features going on there. But after all this, we can say, going through these features of Kotlin, we can clearly say that it's a natural choice of language for Android application development. And Kotlin has many features that improve the functionalities of Android applications, and it has more features with its sleeve. And there is a possibility, tiny bit of possibility, of Java being deprecated with Google bringing all the updated libraries to Kotlin through Android Studio indefinitely, which makes Kotlin the choice. But also, one can always start learning Android development with Kotlin itself, as it is easy to learn too. Okay, so now we have seen basically what is Android, what is the structure of it, how it came to be as a mainstream platform, and which the whole world accepts today. What we need now to make an Android app, what do we need actually? What we need is how to start it, and with the proper guidance, and to start somewhere. Without it, we cannot start anywhere, right? Once basic resources will be given down in the chat by our IEEE faction. And now, on starting the Android app development, we can actually use these, which are Udemy and Udacity, which covers all the area, and you can keep track of your current level here. There is an official also and official Android developers website, and also Google Colabs, releasing tutorials and also releasing libraries, real-time updated libraries of Kotlin and Java onto their sites, so we can study them. Also, and finally, there's our YouTube for the tutorials, which we can use for each basic apps. But we recommend you guys to join the course above, from any of the above, which are free. Some are free, but Google's official Android sites are always free and open source. So next we talk about one of the common things for a developer, which is of course getting stuck on the programming. It might be a logical error, bugs, UI not rendering, and on it goes. It's always depressing for us to get a bad code in our new app that we are trying. And basically for me as a beginner, debugging through the whole app again and again and still not correcting the error can be stressful. But there are many ways to get over these barricades, as I got to know, and we so don't throw your desktop yet. Okay, so one is that there's always communities to help with developers all over the world with the same mistakes or errors you go through, and most probably with a solution to it already. One of the main amazing developer communities is the one and only Stack Overflow, which always has the answer to the errors most of us face correctly by someone who has more experience than us actually. So what is also important here that we can look into logs and reading that reads the state of the Android app, so that we can debug the app from there itself, which is very faster. And with all the sweat and googling things out, you can get more information on this than you can imagine actually. So don't get intimidated by the studio and let's go developing. So when we get to the studio, it's quite resourceful, and yeah, we can get this experience. Okay, so that's all there is for the presentation part. Now let's get into a hands-on session for making a basic Android app. So we are making a dice rolling app of two six-sided dice rolling random numbers and giving the output of the two dice numbers. First, let me show you what will be the output of the app we are going to do. So this is an Android emulator, as you can see in the screen. Oh, you guys can't. Just wait a second. Wait. Okay, so this is an Android emulator we have been using. So yeah, I'll be showing in the output what we'll be making here. So a basic dice roller app with a splash screen. This is called a splash screen, which I'll be explaining later. And the second, this is the main screen. When we click the button, the output will be shown here with each of its sides, and the pictures will be updating itself. Okay, yeah. So let's go now. So okay, so we'll be opening the Android Studio. We'll be making the app from scratch. Okay, so we are opening the Android Studio right now. Okay, so this is what you will see when you finally open Android Studio for a new project. And this is what you will see. So okay, so I forgot to tell you guys one thing about Android Studio is that it is an IDE, integrated developing environment, but it also integrates multiple developer tools for us, to thereby doing a lot of heavy lifting for us. And without it, the development for process will be taking a longer time, and it would be easier to make all sorts of mistakes for us. So yeah, that's about it for Android Studio and intro. So we are here, and first I'll be showing guys around the studio to make you guys more comfortable. So as a start, let me show you the file system that is arranged here. So let's look into the left side, and we can see this and project file. This is the project section where we show where the Android Studio shows the file managing section, and we can manage our files here. So Android actually integrates our files for us so that we can get each file easily. So Android Studio actually our project system, when we click here, we get a project option where we see the basic, which is actually the real option, and it will be a real hustle to take each pages and each code from there. It's very hard. So Android actually integrates us further. When we click on Android option, all the option will be here. And as we see, we can see 3 or 4 types of folders here as the main folders. So I'll be explaining them to you. So the first one has a manifest folder, which actually contains the Android manifest XML. The Android manifest XML file contains the information of the packages, so all the including components of the packages or services, etc. It is also used to protect the application to access the protected areas by providing the permissions. Also, then we have the Java folder which contains our Java or Kotlin codes, which is our logic code of our app. And then we have on our screen, we have our rest folder, which is actually a contains all non-code resources such as XML, layouts, UI strings, and bitmap images, which can be called the UI folder of the app. Next, after we will get onto the Gradle scripts in a bit. So next we can go on to the run and build function over here on the top. Actually, the run actually lets us run the app on this emulator, which will be packaging it for a temporary period for our emulator to work. And for the build option here can make an APK itself for us to publish publish the APK for the into the Google App Store. It's free and we can do it anywhere from anywhere. So just build here and we can publish it anywhere. So let's go into the emulator menu. So emulator menu has the options to select which type of Android version do we want, or which type of device we want for this, and we can choose it accordingly, and we can in the AVD manager. So from here we will be controlling this emulator here by Android Studio. And then we have a major function of Android Studio, which is the logs for debugging. So as I said earlier, when we are getting stuck, this menu down here called logcat can actually let us see what the app is doing right now in the backend. So these messages you show up from the emulator right here, and when we run the app, we have new messages, and we can see what's going on inside the Android app when it's actually running. So it will be easier for us to debug the app when any error comes or it's not working properly. So next, after we have finished the logcat, and let's go. No, before that, I'll be going on to show you what Gradle is. Gradle is kindly like an automation tool for Android. So Android Studio uses Gradle as the foundation of the build system. So with more Android specific capabilities provided by the Google APIs, but also it can store our each in the Gradle folder, our each libraries we are going to import into the system. So like our each implementation, it is called dependencies in here. So it will be adding according to the implementation. And next we can go, we are finally over with the project bar, and now we are going on to the main area. So this is the main, like kindly called the main arena of Android Studio, which is the coding area. So it has like in the Java section, from the Java section we have the Kotlin file, which is the logic code, and from the rest file we have the layout XML, which I actually called as the UI of the file. So actually I preloaded the XML because it will be time consuming to write all this. We will be doing only the logic part of this, and this is the first activity. So an activity, so what is an activity? Every screen of an Android can be called, which is the final output of the screen. One screen can be called an activity. So activities can be used, these are just called screens. So every each activity can be combined from an XML file and a Kotlin file. So these two files actually combine together to form a single activity. Remember that. So in the first we are going with the XML file here. So with the XML file here, let's first found out the constraint layouts. So these are the constraint layout tag for this, but actually what is constraint layout? We spoke of constraints before each things, but we are going to talk about deep here. So XML file have been, that's just the building blocks, building your UI of the thing from scratch. But constraint layout actually is a view group which can contain all of our view tabs like object view and text view right here, and keep them like ordered in an ordered manner, which can fix its position and size accordingly with the screen size. So we do not have to arrange it according to each size, screen dimension, etc. So next we can get into our XML file, and this is our first tag for GIF. This is a GIF. There's a GIF right here as we saw, and for our splash screen, of course, which is the first few seconds screen we show before the main screen, and this is the text view here. So each tags here contains the properties. They are explaining every sort of properties here throughout, and this will these all code are for the position of the this single object, and we can give them single based IDs, and these can be used. These IDs are basically used for connecting it to the logic codes, which are the Kotlin based codes. So we call from here, we apply them here, and we call them each according to our needs to the Kotlin file. So yeah, that's it. Yeah, we are going with the dice roller. Yeah, we are giving everything here. Also, we can also in the XML part, and the Android Studio has a feature called design too. We can just basically not code anymore. We can just drag and drop each parts as we like. But yeah, we can also code single code controlling every functions of the each objects. Yeah, and there's also a split view we can, as we saw earlier. So moving on to the main activity.kt. So this is the main activity code Kotlin file will be saying. So yeah, this is the package name we have selected as before, and this on create function, inside this on create function we create, this is an whatever code we write inside this on create function, when the app opens, whatever functions we write, whatever code we write here inside this will be the first function that uh, runs here. So basically what we all write here, when the Android starts itself, when this main activity comes onto the screen, yeah, we get this running, this part. So first we are doing in the splash screen, right, as we saw in the emulator. So first only a basic little code is needed here, so I'm going to add this code. Okay, the code's been added, so I will explain what this is. This is all what is necessary for the splash screen to appear and disappear in front of you. So this post delete section here, yeah, random, we are using, yes, we are using random function here for the dice, but actually for making it look more dramatic, we are using our splash screen too for when we first open our apps. So yeah, that's it. So this is our first code for, this is just the splash screen. We have finished our flash screen activity. So postdel actually delays the seconds for 5 seconds and then runs our intent. Actually, intent is meaning for getting into one activity to another activity. We call them intent. So intent activity actually lets us get one to another. So before this, we have to create another activity, right? So for this, so we are going to Java, right clicking on Java, click new, and going to activity and creating an empty activity here. So they'll be asking us names. So we gave them a symbol to the name to the main page, which is dice roll. Yep, and another activity is finished here. So yep, we are renaming it according to that. Yep, and the red is gone. So yep. Okay, so Gradle progress is in shown, as it means the Gradle is working on our making our new activity in good hands. So yeah, it's been made. Yeah, no, it's still working. So while it's working, we can add our new XML file from before. It will be inbuilt. It is already made. So I'll be copying it to here so we can save some time. Yep. Yep, and the XML code is here. So these are just, we will see how the app comes out here. Yeah, the app is ready. The basic font is ready. So we are this. Wait a second. Okay, yeah, the basic UI is ready, but we still need to make up our logic file. So this is the final screen, everybody. So we'll be clicking here, and this has a change. But now it will not change. because it's blank. So yeah, we have to add everything by one. So first, I have said this is the region where all the when the screen comes up, all the code works, where all the code works. So this is where we will be. Uh, this is where we'll be adding the our button where in the XML file, where in the XML file we have added. Yeah, so this button here, we have added button here with the inbuilt XML doc we already have. So we gave the ID to the button as button itself, just one button, right? So when we click this button, it have to go to another function. So in the Kotlin file, we are registering, we are giving the value of role button to a thing called button. So actually this happens as we are having not imported the button. Yeah, okay, it's done. Okay, so we are giving the button value from the ID, we are calling it from the XML file, and when we are giving the button a one-click listener after this. So after on this, when this on click, when the button is clicked, the roll dice function will start. Before that, we have to make it so that the screen is not blank. So we have to make it look like this. So it will not come, it will not be available to you as this, it will just show a blank screen. So we have to add the screens from the start itself, just a screen for just showing. So we'll be giving a function called start here. So next, so this it's the only thing that's happening on the main on create function. So we are putting it outside and creating a function called start for basics. That's the first step we do. So when the app creates itself, so when the app creates itself, the images will be shown here already. There will be no blanking. So blank screen available there. So yep, that's done. Yeah, we are importing our image view, and we already have the drawables here. That's one thing I forgot to tell you guys. These are the resource manager where all the drawables and another other stuff is here. So we can add a drawable by clicking add button here and importing that drawables. So from here, it's already been imported here from the Excel to the XML file. Okay, yeah, so yeah, this is the Kotlin file, and we have reached till start where we place just the Android app dice images to the screen. So next we have to put the roll dice, but before that, as part of you, I said oops, we have to create a class of dice, just registering dice as a class for giving out two images. There's two dice, right? So giving, not giving functions to each of them separately, we are going to give them a class dice with our number of sides, and we are giving a function called roll. When it rolls, we are giving as random function, as I said earlier. We are giving just, this is the main function here. So from 1 to whatever value we give, it will give out a random number, and it will show to it will return our number. So next is the final step, guys, and we will be creating a roll dice function here. So that will be another function we'll be creating. So let me just copy it. Okay, so yeah, it's a little big, but I'll be explaining everything every little detail. So first, yeah, when we click on the button from the on click listener, it goes to the function called roll dice. First, it's called toast, a thing called not a bread toast actually. So yeah, it will be toast is actually a function where you've seen in the Android app, when we roll the dice, image will be popped, a message will be popped up below called dice roll. So that's actually called toast. So we'll be making a toast, making text, and yep, the dice roll text. And from then we'll be adding, yeah, text view library. So there's no library imported. Yeah, for every error that come, Android Studio will automatically detect them and give us highlighted as red. So I will be hovering up upon them, and the base, if they have the necessary solution, they will already list them, and we can already do it. It will, and Android Studio will do it. So yeah, and we'll be giving So here we'll be calling out dice as a class from the class given below from the oops concept we learned, and dice with number 6 sides. And we'll be rolling our with roll one. Our first roll is that, and with dice dot roll we call this function here from the random, and the particular number is gotten. So from this we have to set the image as the number. So next we will go to our dice image, which will be given. We will be declaring the image view from before we declared. So, and when roll one, this function is a condition function. When we show that which roll number function will come up with on according to the number, the particular image will shown up here with the respective images of the dice. So just like that, we can, similar to that, we have just made a copy of this with, we have changed the variables as dice to roll 2, and from with roll 2 according to each numbers it will also change. So it will be two different dices with two different numbers, with two different dices with two different random numbers with the function of single random. Yep. And that's how we have finished our app, guys. And yep, I think we can run it. It will take some time, but of course, yep. And yeah, let's see the fruits of doing. Okay, guys, we reached this far too fast, I got, I think. So if there's any doubts, you can ask me doing this Gradle building, if there's anything. Okay, it's lagging a bit. So yeah, yeah, this what we did till now will actually make a app like this. Okay, I have to start clicking, I guess. Yeah, this app will be formed here, just like this. Yep, and our dice app is completed here. Okay, guys, so I think our app is done, and yep, so that's it. We have completed all the basic necessities for building an Android app. So this has been fun, guys, and I hope you guys learned a lot about Android well enough to start on your own. And actually, if you guys have doubt, please comment on our chat section below, and we will be also providing resources for this session in the chat. Please look out for them. And now I'm handing over to Alok for taking the iOS development section next. Okay, thanks, guys. Hey,
Hello,
Alok.
everyone. Hey, Jasim. It was a great
Yep.
session.
Okay, yep,
Yep.
bye.
So let's move on to iOS development. So I'm sorry if there is a light issue. There's a slight power cut at my place. So uh, let's just get on with it, right? So iOS app development. Hello, hi everyone. I'm Alok. I'm a BTech computer science student from VIT Vellore. Today, we're going to take a good look into how iOS applications are built and what's behind them. So let me ask you a quick question. What is iOS? It's a pretty simple one. So you've heard the name iOS, right? So what exactly is iOS? Yeah, iOS is Apple's mobile operating system, and it runs on iPhones and the iPod Touch. So, released on June 2007 with the first generation iPhone, it is the operating system that even used to run on iPad when it was released in 2010. But then recently, iPad OS was released in 2019. So, since then, iPad is running iPad OS. So, by the way, do you guys know which iPhone this is? Can you guys guess um, what iPhone this is? Can I see it in the comments? Yeah, this is the latest released iPhone. It is not the iPhone 10, it is the iPhone 12. So it is the iPhone 12, and I'm going to show you guys three quick pictures of three iOS devices, and please see if you find any similarity between them. This is the iPhone 5, technically the 5S, one of my favorite makes of the iPhone. This is the iPhone 10. So notice these features of these three iPhones. Okay, there is the iPhone 10, there is the iPhone 5S, and there is the iPhone 12. So, did you guys notice any small detail? All these iPhones have this time 9:41, right? There is this time 9:41 in each of these iPhones if you notice carefully. Why? What is that significance of that time 9:41? So each and every iPhone is released in this time from the first iPhone that Steve Jobs released till date. So Apple events always are planned according, the keynotes are planned such that after 40 minutes is when they release their first actual first main product of that keynote event. All right. So that is what is the So there are more than 1.7 billion active iOS devices in the world today. And when you talk about iOS, the app market of iOS is called the App Store, right? So in Google and Android, it's called Play Store, and the app market is called App Store. So how many apps do you think the App Store holds? We saw in Android earlier some numbers, but now what? How many apps do you think? There are about 200 million apps on the iOS App Store. And even in Android session you saw earlier, what was the revenue that Android received? It was about 38 billion. But in this in iOS App Store, $64 billion was App Store's gross revenue in the year 2020. So that is how popular iOS development is and how special it is, right? So we are going to see how these apps are made and what is behind them. So first of all, being an iOS developer, you should know what do you start, where do you start with, right? So what do I need to start with iOS development? One, you need a Mac. You need a Mac, any kind of Mac. A MacBook is shown here. It can be an iMac, it can be a Mac Mini. But even recently with iPad OS 15, you can run Xcode on iPads, right? So with the new update, you might be even be able to develop apps on the iPad Pro. So the next logo that you see there is Xcode. Xcode can be used to develop apps for all the Apple platforms. It is the integrated development environment that Apple first launched in 2003 to develop applications, right? So, but we have Xcode and we have the Mac. But what do we need? We have a development environment and we have the system we need to develop. But what is next? What language, right? So when iPhone first launched in 2007, iOS applications was developed using this language called Objective-C. Right. So Objective C was originally developed in the 1980s, and Objective C was something that made the C language object oriented. I guess Jasim had explained a little bit about object oriented programming, OOPS style programming, and even you might have learned in your school or college. So, but eventually, Apple made their own language called Swift in the year 2014, which is again an object oriented programming language which is focused on app development. So today, people don't really use Objective C because one, it's old, and two, we have Swift. Swift is like a bomb, right? So we're gonna see how great Swift is with these quick points. So Objective C syntax is no, you don't need that. So we have these cool points of Swift here. So let's just go through each one of them. So a clean syntax. So compared to Objective C, you saw a meme back there, right? Compared to Objective C being an old language, Swift has a much cleaner syntax, which is more readable and easily understandable. And the next word is interaction coding. So interaction coding is something called as live coding. So usually what happens in a programming language, say Python or C, you type a code, you write the code of the program, and then you compile it and then you run it, right? So there is this compilation thingy there. But in Swift, you can actually write the code when it's running real time. So while it's running, while you're writing the code, you can see the output of the code. You can get results or errors just when you're typing the code. So yeah, that is what is interaction coding. Now less coding. So compared to Objective C and Swift, you'll be able to see that you'll have to write much less code for a large functionality, for a lot of functionality. And again, the next point is safer platform. So when it comes to mobile applications, you can't really have errors. So a code is unsafe when there are errors, and errors in a mobile application is real bad for a user. So Swift has been developed keeping in mind about this. So there are tons of methods in Swift like guards, that is optional, where you can prevent such errors. Again, because of all these points, we have speedy development using interaction coding and the clean syntax and everything. We have speedy development. Then the next, now the most important point that people don't know, the most people don't know, is that Swift, an Apple developed language, can't really be called Apple developed, completely Apple developed, because it is open source. It is supported by the community. So it is supported by millions of developers across the world. Because of this, you can find that even some components of macOS and iOS is made open source by Apple, and you can all find that out in opensource.apple.com. So, and that is why, because of all these points, is why my favorite language that I've ever coded in is Swift. So, I'm showing you a couple of pictures here. Can you guys just say what all devices are these? Just let's just see some interaction in the comments. What all are the devices that you see here? You have some famous devices, mostly famous devices because it's Apple. Yeah, we have the TV, the Apple TV, the Mac, the MacBook, the iPad, the iPhone, the watch, the Apple Watch, and what all are the operating systems that runs on these devices? There is tvOS, there is Mac OS, there is iPad OS, there is iOS, our favorite, and then there's watchOS. So this is what is the Apple ecosystem, and using Swift and Xcode, you can actually develop applications for all these. The experience that a user gets with all these devices together is just impeccable. So even as a developer, you can actually have the same code for all these operating systems, which we'll see in a bit, right? So so now moving on to application development. So there are two types of development. There is storyboard and there is Swift UI. So you can develop iOS applications using two methods, storyboard and there is Swift UI. So yeah, what is storyboard? What is storyboard in real, like in English? What does storyboard mean? Yeah, storyboard is actually like when you make movies, storyboard is what someone uses to, what the scriptwriter uses to make what he thinks of, right? So when he has a vision in his mind and he wants to make it on camera, so that is how people like that is what is storyboard. So imagine iOS applications as a story. So we have the app launches, then it clicks on a button, then it goes there, then it comes here. So all these features can be seen shown using storyboard, right? So let's just look what actually storyboard is. I'll just share my screen again. um, Yeah. So you can see this app right here, and this is what is storyboard. So we've got some cool UI here, we've got something here. So you can just drag and drop whatever you need in the graphical user interface. You can align it wherever you want. You can move this here, and if you want to add a button, you just go Command Shift L, and you can see this here. You drag a button right there and place it wherever you want. If you want that button to go somewhere, you add something called as a view controller. So view controller means basically screens in iOS. You can just see it like that. So if this button, when the user clicks there, you can just drag and drop it and decide how it should show. If it's just a show detail, present modally, with some animation. So we can just click on that, and then you see this connection right here. So this is all that you need in iOS when you're talking about the UI of the application when you're developing using Storyboard. So then there is, we can just look at all these files right here. So then there is viewcontroller.swift. So this viewcontroller.swift is what the code is, where the code is, or where the logic of the program is. So you connect the main.storyboard with the viewcontroller.swift by using just these. I'll show you how. So we've got viewcontroller.swift right here, and then we've got our app here. So we can just control click on this button. This is a button, and just drag it to my code. There it is. You have an IB outlet. So you can give it a name and just connect it, and you can code it whatever you want. So that is how these apps run in iOS. This is the storyboard version. We are going to get into something called a Swift UI, but this is the storyboard version. This is a quick demonstration of the app. Yeah, so when I just click, say Alok, and done, it just say hello. Simple app is that. Hello, CT, CT. So if you notice here, the text box is kind of outside the screen. So you need to set something called as constraints in here, which says that it should not go out of the screen and all of that, right? So before that, let's just get into what Swift UI is. Yeah, so we've got storyboard here. And let's move on to Swift UI. So Swift UI is a modern way to declare your user interfaces to any Apple platform. So we've got, it is something called as a declarative framework. So now what is a declarative framework? Let's see. It is something as UI is equal to f of state. UI is a function of state. So say y is equal to f of x. X changes when y changes when x changes. So that means exactly what is here. So UI changes when the state changes. Now, what is state? State is data. So when there is a data change in our application, then the UI completely rebuilds, right? So that is UI is a function of state. So again, Swift UI. So Swift UI is a you can use lesser code. You have faster development, less prone to errors. So you see all these apps right here. The one on the Mac, the one on the iPhone, the one on the Watch OS is all has one single code. So that is how efficient iOS is. So Swift UI is just great. So Jasam made a quick dice roller app, right? So he took about half an hour for that to make. Now let's just try the same using our Swift UI. So we create a new Xcode project. I call it dice roller, and then I create it. And then we just wait for it to load. So all these problems that we have in Storyboard can be fixed in Swift UI. So, and it is all just code. So you don't have a separate storyboard file or a XML file that we have to like deal with the UI. So it's all just code. So we have a preview right here. So this is a content view.swift. So content view.swift is where holds the actual view of this app, and the app itself holds the content view. So we have this preview. We talked about the preview earlier. So this is the actual view in Swift UI. So when you Yeah, so we have an iOS device right here. So that just says hello world. I can just change it to hello CET and it just changes. So that is how quick it is. You can have live displays. So let's just take the assets that Jasi gave me and just put it up in here. So we've got assets. I'm just going to drag and drop the assets, save it, go to content view. Now we have a VStack. Something called as a VStack is a vertical stack that stacks on UI stuff. And then we can have a text. Roll the dice. And then uh, let's have another 8 stack, which is a horizontal stack. So 8 stack of images. Now what we're gonna give in this image? Remember what we said about state? See, that image is so big, we're gonna reduce the size. So the state, I'm going to create a state variable here. So what does that mean? When you have a change in the state variable, you have a change in the whole UI, right? So we are going to have this, copy it, paste it right there, D2, second image of D1. I'm just going to resize it. We got image of, okay, got resizable, dot aspect ratio, dot fit. We've got the view here, so we've got the image right there. Just copy it, do the same for the D2. So we've got the second image there. Now let's add another 8 stack uh, for this text. And then let's add the button. And the action will have a code which is going to take what is in D1 and just give a random int. Yep, we're gonna copy that and we're gonna paste it here. D2, gonna give some spacing here to look better. We're gonna decrease the images with some padding. Yep, yep, we have our app ready. I can just click on roll. That's it. So that's how fast you can make apps in SwiftUI. So we can run the same app on say an iPhone 12. Add a spacing here right then. And Yep, this should work. Yep. So we have the app here. Roll it. Any app, you get the same screen, all the UI is set up. We can just perform any changes in the UI as simple as that. This is all the code that's needed. You don't need to have an XML file or a storyboard. Any other file that you need, you don't need. This is just the all the code that you read. Right. So let's move on to our slide. Again, the UI is a function of state. Now, so we're done with Swift, but is Swift done? We don't really know, right? So Swift is a lot powerful than that. What you think? You've got a lot of frameworks in Swift. So what is a framework? Framework is a software or some code that provides some sort of a generic functionality for particular applications, right? So let's just see some of these frameworks here. Can anybody say what these frameworks are? What do they look like? Or there are some letters there. You can just read them and say what it is. Yeah, there is something called ML. Have you guys heard about the term ML? Yeah, ML kit. It's not actually ML kit. It is something called a score ML. So yeah, ML full form. We've got Shubham replying that AR kit. Yeah, we'll look into that. So what is ML? ML is machine learning, right? So you can actually implement machine learning models in your application using this framework in Swift. And the next one, as Shubham said, AR kit. Now, AR, what is AR? What is augmented reality? Right. Augmented reality is this experience, an experience of a real world environment using computer generated objects. So, some sort of an object we generate using our software or our code, and we make it possible in the real world environment about us. So, Pokemon Go is a pretty famous app that is made using AR, that uses the functionality of AR. So ARKit, you can actually implement AR in iOS applications using this famous ARKit. And another one, the third one is WidgetKit. And WidgetKit was released last year, and there was a lot of memes about how iOS released it late and something. But WidgetKit is the best. Is has a lot of features that you can use to create widgets, and it's much better than the Android widgets you have. Yeah. Next we have is WatchKit. Now WatchKit is provides infrastructure for creating watchOS apps, any kind of watchOS apps, you name it. You can have WatchKit do that. The this one right here is iCloud. So we have the Cloud Kit for iCloud. We have Google Drive for Android or Google, but we've got iCloud for iOS applications. So CloudKit, you can implement iCloud in iOS applications using this CloudKit framework. Can anyone guess what this one is? What the next one is? It is something called a Sprite Kit. Right, Sprite Kit. Using Sprite Kit, you can actually make 2D games, and for creating shapes, particles, texts, images, videos. All this can be created using Sprite Kit. And then we have something called as Metal Kit. So we called as yeah we have Sprite Kit there, but that is used for 2D games like Flappy Bird, Super Mario. But what about 3D games? For 3D games, we have Metal Kit. Metal Kit is pretty great for creating textures and all, textures, light, shades, and all in our app. The next one is Swift UI. So Swift UI is again our what we saw earlier. So it's pretty great as you see. Then we have this one, which is not really related to mobile. It is a web backend framework called Vapor. Yesterday, you saw in Varun and Harsh's session about MERN what backend was, right? So this you can actually develop a website's backend using Swift. That Vapor is a framework used for that. So we can't really talk about Apple without talking about its Apple's events, right? So, and one of the most important and exciting one is the WWDC. So WWDC is the Worldwide Developer Conference. It is happens in June every year, and it is where Apple releases all of its software, all of its new development In this WWDC 2021, we had iOS 15, and even we had macOS monetary release this year. So, along with WWDC, we have something called as Swift Student Challenge. Swift Student Challenge was earlier called as WWDC Scholarship, where you actually get a ticket that costs about $1,000 to the WWDC for the students. But Apple changed that policy, and now it is called a Swift Student Challenge. Swift Student Challenge is actually a challenge where you can create a mini app, not a complete app. You can create something called an app in something called as a Swift Playground, right? So a Swift Playground is a smaller version of the Xcode. So you can create apps, implement some sort of an idea, and you can get into Swift Student Challenge. You can get Apple goodies and stuff, right? So that's all for iOS, and we have all these resources that we have. We've got our YouTube, we've got Udemy, our favorite GitHub, Medium, Stack Overflow, Udacity, and you see something called as HIG, Human Interface Guidelines in the style. So what is Human Interface Guidelines? So Human Interface Guidelines is the guidelines that Apple set for developers on how to create their apps, right? So if you want our apps, Apple wants has a set of rules of where the UI should be. If we click on a button, how it should look like, and where a button must be placed, and it's all based on the UI, user interface, right? So that is what is human interface guidelines. So if we don't develop according to the HIG, our apps might get rejected in App Store. So please take a look at that. Then we have the Apple developer documentation and everything. We'll be posting the links at the end of the session in the chat. So and we're done with iOS, and then we're done with Android. So let me put you a question. What if we can write a single code for both iOS and Android? So in these two sessions, we saw that what we saw was native development. Native development means when the app is developed particularly for its own operating system. So we develop iOS in Swift for iOS, Android in Kotlin for Android. So what if we can write a single code for both iOS and Android, right? Uh, I think Jasim will be joining me now.
You're
Yep.
there.
Hey,
Uh,
hey there.
yeah. So Jasim, what do you think? What if we can create a single code? Is it possible?
Yes, we can actually do that, and that is called cross-platform development. And it is the practice of developing apps or softwares for multiple platforms using the same code itself, as Allocast.
Yeah.
Yep.
So how does this work? So we've got this single code here. We've got a bridge here, and we've got the platform specific code. This is how this cross-platform apps run, right? So we write a single code for all the platforms, and there exists a bridge that converts and understands this code based on its framework, and then it is embedded onto that platform. This is how these cross-platform apps work. So we're going to take a small look into what are all these cross-platform apps, famous frameworks and all. So yeah,
Okay, so here's a cross-platform framework called React.js. Yesterday, Varun and Harsh explained React.js as part of the MERN session, and it's written in React Native JavaScript code. Actually, React.js is also made by the famous company Facebook, and React.js is a JavaScript library supporting both front-end web and being run on a server for building user interfaces and
Hello,
web
Farooq.
applications. And
Bingo
of course,
slices and
React Native is a
jackpot.
mobile
आवाज नहीं आ
framework
रही
that
नीचे
makes
चलेंगे ना
use of the JavaScript engine available on the host, allowing you to build more applications for different platforms. On to you for the next one, Alok. Yeah,
yeah,
yeah, and also one more point to be made. These apps shown here on React Native page on the slide is made by React itself, the famous Facebook we all use apps, Walmart, Instagram, and of course Bloomberg. Yeah, and that's about it about React Native.
yeah. Then we have something called as Flutter. Flutter is pretty famous these days. We've got a lot of startups using Flutter. Uh, Flutter is this Google developed framework that has that's something called as a declarative framework. We saw what was a declarative framework in Swift UI. UI is equal to f of state. UI is a function of state. So that is what is a Flutter is exactly same as Swift UI. I mean, it works like Swift UI, and it is cross-platform with Android, iOS, and even web. You can actually develop web apps for using Flutter. So Google Pay is the famous one of the famous apps that is written in Flutter, and Dart is a programming language that you use for Flutter development.
Okay, so the next one is Unity with the C Sharp language. Unity is a game development ecosystem or powerful rendering engine which has intuitive tools, rapid workflow of 2D and 3D games, and eventually an all-in-one deployment support. And Unity is a game engine that was designed by Unity Technologies to develop cross-platform games, which means you can create games for multiple platforms like Android, iOS, PC, among others. But the one among the famous Unity has made is the Android platform itself. So these are the games that were shown by it, like with the famous Altos Adventure. Most of you have probably played. This is the second one is Shadow Fight 3, and this is the Paco Cartis. Yeah, and that's it for Unity.
Yeah. So we've got the next one is Xamarin. Xamarin is something that's developed by Microsoft. It is a cross-platform development framework that works on C Sharp and the .NET framework, right? So it can run apps on Android, iOS, watchOS, tvOS, macOS, and even on Windows. So there are other frameworks like Apache, Cordova, PhoneGap, then there's Ionic. All these are there. But let me again a question: native or cross-platform? So we saw about Android, and we saw about an iOS, and we saw about cross-platform. So which one do you choose? What would you choose, Jason?
So basically, for me, I will be choosing native over cross-platform because of its functionality, which will give with a small amount of code and its speed, of course. But I can go to cross-platform, which is actually based on what we are going to do. To reach a whole audience with a single code, a cross-platform is very necessary, which is actually a single code event for multiple platforms. But
Yeah.
native also has its pros actually with its. Yep. Yep,
Yeah,
that's what I.
the performance that native gives is just pretty great. And cross-platform, the thing is, it's all about money, right? So if you have funds
Yeah.
for making a powerful native app, then you should do that. But instead, if you're like don't have enough funds, you need not hire a native iOS developer and a native Android developer. You can just hire a native a cross-platform developer, which works on Flutter or React Native or something, and develop their apps, which is much cost efficient and a lot better. I mean, in terms of money and time, so you get apps faster. But again, there are these cons where we can't actually have the performance, and we can't have native features of devices. So those are other cons. So at the end, it's all about you, what you want, how much budget you have, and all that. So again, resources will be provided in the comments, and that is it for the session. Thank you,
Yeah,
guys.
guys.
I hope you like it. Yeah, it was great. So bye bye, guys. See you tomorrow with the game dev session.
Game dev
Uh,
session. Yep.
yeah, bye bye.
Okay, that's it.